Hi, my name is Jason Adrians. Today is 12/17/2024, and I'm going to be solving this combined spectral problem and giving my analysis of it and how I got the answer. So the first thing that I looked at, and the first thing that I wanted to figure out when looking at this problem, was the possible functional group that could be within the molecule. And I did this by first calculating the degrees of unsaturation. The degrees of unsaturation was calculated by taking the 2 times the number of carbons, which is 6, plus 2, which is 14, minusing the actual number of hydrogens being 12. 14 minus 12 is 2, divided by 2 is 1. So that meant that there was one double bond or one triple bond within the molecule. Then from there, I looked at the IR spectrum. The IR spectrum is very telling of a lot of functional groups. So with this peak at about 1700 wave numbers, 1750 wave numbers, this is very characteristic of a carbonyl group, a CO double bond. The other characteristic peak in the IR spectrum is a CO single bond at about 1200 wave numbers. This peak at about 1200 wave numbers and this peak at about 1750 wave numbers is leading me to believe that it's an ester group within this molecule. But there's also some other possible functional groups that could be within this molecule, and one of them is an aldehyde, the next one is a ketone, possibly a carboxylic acid. Obviously I mentioned an ester and an amide. I knew that it wasn't an aldehyde though, because there was not a peak at about 20, it's in between 2850 and 2950 wave numbers, and there's an sp2ch stretching that's very characteristic, and this spectrum did not have that, so I knew it was not an aldehyde. It could also be a diketone, but because the 2 oxygens within it, but because of this CO single bond, I knew that it was likely an ester, more so than a ketone or a diketone. The next one is a possible carboxylic acid. The carboxylic acid it has an OH group, so it would have a long, broad peak right here above 3000 wave numbers, and it did not have that, so I knew it was not a carboxylic acid. And then also, if it was an amide, it would have an NH2 group, and the NH2 group would have 2 peaks somewhere above 3000 wave numbers as well, and because it did not have that, I could get rid of an amide. So the immediate favorite for the functional group that was within this molecule is an ester. So that's what I first drew on my paper, was an ester, just to get something down. The other thing that was very significant of a carbonyl group was this peak on the carbon NMR spectrum, which is right at about 175 parts per million, and that was significant in the determining the functional group as well. The next thing, overall, looking at the carbon NMR spectrum, it had 6 peaks, and the molecule itself had 6 carbons, which meant that each carbon showed up on the carbon NMR spectrum, which meant that they were all not equivalent. So there was no symmetry within the molecule, which is also convincing me that it's an ester as well. So now I just had the ester group drew on my paper, and the hydrogen NMR spectrum actually made me let me finish the molecule. The first thing I looked at within this hydrogen NMR spectrum was the peak at about 4.1, 4.2. Actually, backing up, the integration numbers. So the formula was C6H12O2, and I already had used one of the carbons in both oxygens. So I was basically trying to figure out where the rest of the carbons were and where the hydrogens were. The integration numbers that were here, 2, 2, 2, and 3, and 3, this basically showed me that where the rest of the hydrogens were. These all add up to 12, so that I knew that it wasn't simplified at all, and all these peaks were as they should be for the molecule that I had started to draw. So this peak here, with it being super far downfield, or not super far downfield, but fairly downfield, I knew that it was going to be connected to one of the oxygens because the oxygen has to take away some of the positive character of the hydrogens. And because the integration number was 2 and the multiplicity was a quartet, I knew that this one was a CH2 group that was bonded to the oxygen that was single bonded to the carbonyl group. This was because the CH2 group, or the 2 integration number meant it was a CH2 group, and it had 3 neighbors because the other 3 peaks. So that meant it was a CH2 group bonded to a CH3 group. The CH3 group is the terminal CH3 group. So that basically was convincing me that there was an ethyl group to the right, or it doesn't really matter, to the right or left, but it was bonded to the oxygen in the ester group that I drew already. This is kind of how I interpreted it there. So this was the oxygen that was bonded to the single bonded oxygen to the carbonyl group, and then the CH2, CH3. The next thing that convinced me was the peak at about 1.3. This was a triplet, so I knew that because the integration number was it was a CH3, and it was a triplet, so it was bonded to another CH2, and I roughly drew in an ethyl group to the right of my ester functional group, and this ethyl group, I basically confirmed it with these 2 peaks here. The next thing I was looking at is trying to figure out where the other carbon and where the other carbons and the other hydrogens were. And the next thing I looked at was this sextet here. So this 2 integration number meant that it was a CH2, and it had to have 5 total neighbors. So that meant I knew from that it was bonded to another CH2 group and a CH3 group, as I wrote down here. This was off the carbonyl group that I drew in, and well, technically the ester, but the carbon was bonded to a CH2, and then the middle one was the sextet in the technically the butanoate part of the ethyl molecule, or the ethyl butanoate molecule. So it was this carbon right here was the sextet, and then the other peaks here just confirmed this. So the 2H integration number meant the CH2, and then it had 2 other peaks, so N-1. It meant that it had 2 neighbors, which was the CH2 group that was I had drawn in already, this one, and then the 3H that was more upfield and further away from the ester group. It was a 3H, so I knew it was a CH3, and then it was a triplet, so it had 2 neighbors, and that was the CH2 group right here. And that explanation basically is explaining what all this says right here. So based on my analysis, I'm pretty positively can say that the spectrums that I'm given and the molecular formula I'm given line up to be ethyl butanoate. And thanks for listening.